Hi guys, so this is a video that I've been meaning to do for a while, and it should be obvious by what you see in front of you that something is about to die horribly. So a lot of you will have bought stuff online from places like Wish, Aliexpress, eBay, and you'll be well familiar with the absolutely awful mains leads that they come with, these things. So why are they so bad, and what happens when they go wrong? Well, let's just zoom you down. The other question I'm answering here is somebody pointed out on the mains monitoring module that should I really be using anything on the mains that came from Aliexpress? I did give an answer there, which I'll go over in a minute. But anyway, here we have a standard UK mains plug. Notice that the top earth pin is unshielded. It's longer than the others, and you'll notice that the two main conductors have plastic shields on. It is manufactured to UK standard BS 1363 or 1363A, which mandates all sorts of protection features and is one of the reasons why this is one of the safest plugs in the world. Let me just zoom you down. I'm not going to go into a great long video about the virtues of the UK plug and everything, because there's plenty more of them. But one of the things they are really good for, if you leave them that way, they really hurt when you stand on them. Unlike many countries, we actually have a fuse in the plug. Now, the UK ring mains are generally fused or protected by a breaker at 32 amps. The largest plug fuse you should find is 13 amps. And the cables are generally rated around the 32 amp range as well. So everything is set up so that if something goes horribly wrong on this side, plug fuse blows. Normally the breaker will go as well. If you have a wired fuse, there's not many places left with them, but if you do, that may or may not blow. It depends on what blows fastest, but certainly with breakers you'll normally take everything else. It means that this is fairly safe, and the most common way of zapping yourself used to be by touching these when you were putting them in and out. It's certainly something I did many years ago. So yeah, there's a level of safety in there, and the flex is good, solid, high quality flex. So, you know, there's some effort been put into it. So let's look at this thing. Well, it's first obvious that there is absolutely no fuse in here at all. So this horrible, cheap, nasty cable here is going to be expected to absorb 32 amps, and as Project Farm says, we're going to test that. We've also, for some reason, shielded the earth pin, which means we've understood what the plug looks like, but not why it looks like it was. So yeah, not quite sure why we shielded the earth pin there. It serves no purpose. You could arguably make things slightly more dangerous. I have seen plugs where the earth pin doesn't actually slide into a contact as these do. These quite often sit into a cup, but I have seen on the earth pin, because this is used to open the gate, where the contact slides up. So the contact point is actually up here, which could, in that situation, leave you without an earth. Now, this is actually an external 12-volt power supply for a CCTV camera. This is designed to go outside, so already, you know, we're into some fairly major problems here. You know, you wouldn't use that. And as you can see, there is no sealing there at all. High quality, and it's really well put together. I mean, it's really waterproof. That's all there is. There's no sealing on here or anything. It's cheaply made, as to be expected. There is no input filtering. There's no input filtering. There is a glass fuse there, but I suspect this is built from the data sheet of the control chip, and yeah, there are a lot of parts missing in here as well. I wouldn't trust it. Annoyingly, the isolation in here, well, it isn't too bad unless you consider where that mains cable is sitting there. we're rather close over there, and this is again, it's low quality cable, it's not particularly well bonded. So what we're going to do is we're going to show you what should happen. So we will take our 13 amp plug. We have a high current DC power supply on here, and I can never quite remember which one is live on these, so we might have to take a punt. So, and there we go, fuse is gone, no problems. What do we think is going to happen with this other thing? So we'll go on the live again, like so. Can you see that? There is a very good reason that I'm doing this the way I'm doing it on my board. And where are we? So that there is our live. And I'm going to pause because I think there's going to be a fire alarm any second. So that was slightly more energetic than I thought it might be. And just to be clear, this wasn't AC mains, this was just low voltage DC. This was 20 or 30 amps at 12 volts, so nothing major. If that was wrapped round other cables, wrapped round furnishings, or just lying on a carpet, it would have set things alight. So if we have a look, you can see what saved us here. The live conductor actually separated. I need to check the video footage. That may have been red hot at the point that it failed. And you can see it has failed completely. It has completely gone. As I said, if that were wrapped around something, that would have been a problem. And had that conductor have not failed, that would have just become a big heating element. I mean, no, let's leave that for a second. Let me take this out and cut the ends off, and you can see that it has blown holes in the cable along its length. If you'd have watched the video clip previously, you'd have seen that the smoke came screaming out of those holes. So let's just cut these ends off. You can't see quite clearly because the camera doesn't want to focus on something so small, but you can see that the live conductor in there is toasted as well, so it's probably failed inside the plug. We'll take this end off as well, and what I'll do is I'll just cut in here, and then we can pull this apart and have a look and see what the carnage in here is like. So stripping this here, immediately what I can notice is that there doesn't appear to be any actual damage visible here, so all the damage has happened on the outside of the cable. It's interesting that the live conductor is not actually damaged. And also look at the colouring of these conductors. It's pastel colours, they're not really good distinguishing colours. And if we pull this out, you can see the damage on that conductor. So there's holes in this. There's another hole there, and you can see where it's blown the plastic out as it's melted. And again, had the fuse not failed, let's just say for a second that the power supply failed and left this live, the fuse didn't go or the breaker didn't go, you've now got a live conductor poking out the side of the wire, and someone's going to pick that up and get zapped by it. The fuse failing would have stopped that. That's really, I mean, potentially that would also have become red hot. The other danger is doing that, it may have shorted to the other conductor inside the wire and just fed it back. So that's the difference between the way this should be, and that's why these fuseless plugs are so dangerous. And just to touch on what was said in the other video, this is a sealed unit. I don't know what's in it. I have no control of what's on the end, and ideally I shouldn't have been able to get it open, or you know, I shouldn't have been able to get in there. The power supply doesn't actually look that bad. I still wouldn't trust it. It's cheap, cheerful, built from a data sheet I suspect, and the output is probably horrible. but I've never plugged this in, and I wouldn't plug it in. As I say, we know that there are some real bad power supplies out there, and I can't see inside this. I would not trust it. And yes, this is starting to feel like a Garage 54 video. We have another one here which will be going straight in the bin. So this is the difference. This is what I was trying to explain. I don't know what's in this power supply. There's no way I would use this. There's no way I would buy something like this from Aliexpress, Wish, or somewhere like that. The module that I showed in the previous video, I can see the way it's built, I can see the components that are used, I can see how it's put together. As we touched on, there was another version of it with some creepage problems where there was a ground plane pour between the optocouplers, potentially breaching the isolation. But with the one that we looked at yesterday, we can see that there's slots milled in there. We can see that the ground pour does not extend past the opto isolator, and there is good isolation on it. It's something that you can check, something you can look at, something you can hold in your hand and verify yourself that it's good. At the end of the day, it comes down to doing due diligence. If you think you're able to make sure that the item is safe without tearing it apart, then you should be good. Anyway, catch you soon on the next video. Bye.